All right, moving on to equations that include our rational number coefficients. The question says, do fractions change how you will solve this equation compared to the one before? And of course, the answer would be yes, it does. Because before we can start any solving, we want to go ahead and clear these fractions. Okay, so looking at my two fractions here, this one's going to be a little bit more simple because they both have the same denominator. So in order to clear the fraction, all I have to do is multiply each number in my equation by the denominator since they are the same. So I'm going to go ahead and show my multiplication on all numbers in my equation. So I'm multiplying everything times 5. And if you put this in your calculator, 5 times 11 over 5, you'll notice that it gives you whatever the numerator is. Or you can start to notice that when you are multiplying a number times a fraction, if you're multiplying by the denominator, it cancels it out. So this will become 11x. We've got positive 10 here equals, once again, we're going to clear the fraction, so we're multiplying by the denominator, so that cancels each other out. Or you can think of it as 5 times 3 is 15, and 15 divided by 5 is 3, which is your numerator. So we get 3x, and then 10 times 5 is 50. And then here we have just a basic equation. So we're going to go ahead and move our variables to the left, our constants to the right, and go from there. So we're going to go ahead and get rid of this constant, move it to the other side. We've got 11x equals 3x plus 40. I want to move this variable to the left side, so I'm going to do the inverse operation, so I'm subtracting it from both sides. 11x minus 3x gives me 8x equals, that cancels out, and I bring down my 40. And last thing, to solve for x, I'm going to go ahead and divide on both sides by 8, and that gives me x equals 5. And once again, you always want to go back in and plug in your answer into your variable to make sure that it equals the same on both sides.